This is a presentation on Happy or Not, a case study on real-time customer satisfaction measurement based on research that was conducted while I worked as a Fulbright Finland Foundation-supported scholar at Turku University of Applied Sciences in fall of 21. Traditionally, customer satisfaction has been measured through surveys and focus groups, which is typically rich but memory dependent. And so it fails to provide direction because a lot of times companies know that they have received some survey data, but they just don't know what it means. Another way to collect customer satisfaction data is online, but that only measures those who get to complete the transactions. And if you are in the middle of the transaction, you leave the website, you don't really get a chance to complete your customer satisfaction measurement. So that is, again, has some limitations. Another way is to use real-time data using cell phones. And the problem with that is that it fails in the area of privacy and anonymity because it doesn't, you know who is actually responding. And it also requires the respondent to continue to respond, which places the burden on the respondent. So although it might be beneficial in capturing all stages of the customer purchase journey, it fails the area of privacy and anonymity. So there's an alternative form of almost real-time measurement, and that is what the focus of my research study is on, and on how this kind of measurement can be helpful in guiding decisions in terms of actual operational changes that you can make to increase customer satisfaction. So the company that I work with is a Finnish company called Happy or Not, which is a global company, and it measures customer satisfaction using these emoticons. So the idea of Happy or Not was conceived by Heikki Vanhanen in 2008. And Heikki recalled that he had bad customer service from a local retailer growing up in a small town. And he decided that it did not have to be this way. So the idea was really simple, but it has generalizability across generations of changing customer behavior and technologies. So the idea was to build a physical terminal with 4 smiley faces representing very happy, happy, little happy, and little unhappy and very unhappy. So customers could simply respond to any service by pressing one of the buttons, providing near real-time feedback on the experience. So you can see that there are 4 emoticons that I used, and they have 2 different products. One is a dumb terminal, which only requires the respondent to respond right after they have received their service. The other one is slightly smarter, but then it increases the cognitive burden placed on the respondent because you can ask them why they're responding the way they're responding, and you can increase the number of questions since it's based on an iPad kind of device. But then the dumb terminal can be placed anywhere, and it simply has a battery. It doesn't need any electrical power outlet either, which increases its flexibility. There are other competitors who are providing very similar kinds of services with some changes. So there is another company from Finland that has a 5 emoji button here. And it's also touchless now, given COVID. And it also provides the QR scan so people can respond to it. So it combines the after the fact memory-based kind of measurement with the real time. There is another Swedish company which also has a 5 emoticon scale to measure experience. Then, of course, there's Qualtrics, which is well known, but Qualtrics does not have, although it uses emoticon-based scales, it is not necessarily a device that can sit at the place of service. to get immediate response on experiences. So this is more of a web-based, emoticon-based measurement. So when we compare with other methods, this kind of method captures emotions as and when it happens. Typical customer satisfaction measurements rely on after-the-act memory. And typically, the response rate is far higher through these systems, and there's less cognitive burden to respond. So the company that I worked with that had this installation is at BioCity, but managed by Arkia. So the company was Arkia, which is an incorporated corporation through the city of Turku, and it provides food cleaning, property management, business premises, and building services. And the installation of the Happy or Not device, which was a dumb device, a physical device, a standalone installation, was at BioCity, which is a building that has many offices as well as classes for the Turku University of Applied Sciences. And this was at a public bathroom. And Arkia manages the public bathroom in terms of cleaning that is provided. But the device is from Happy or Not. And this is a typical device. It's just a little standalone which can be placed on the wall. And it says here, Oliko WC Tila Sisti, which in Finnish translated into English is, was the toilet clean? And so this was the device that was recording the responses. So if we look at antecedents and importance of customer satisfaction has been shown to be related to shareholder value. When it comes to something that is related to bathrooms and how crowding has an effect, we know that research has shown that there's perceived crowding has an effect on customer satisfaction when shopping at retail stores. And recently, they also showed some of the same researchers showed that it's also moderated by beliefs about the threat of COVID in terms of how much it has an impact on satisfaction. Cleanliness has been shown to be important in terms of how a restaurant is perceived in terms of, it's seen as an indicator of food safety in restaurant. And there have been many other studies done in this respect as well. So both of these are applicable in this case, where we're looking at customer satisfaction with the public bathroom, perceived crowding effects, as well as cleanliness and hygiene should have an impact. It's expected on customer satisfaction. So the typical data that is collected through such devices is both machine-based as well as customer response-based. So the customer response-based data that is collected is in terms of what the customer picks in terms of the level of indicating the level of happiness or unhappiness. And then the machine records the date, time in seconds. And it's also possible by looking at the data, because the volume of the data, you can also look at the number of responses. These devices are quite applicable where there's high volume. There's a possibility of high volume of responses, such as a retail store or any kind of public setting where there might be a high level of foot traffic. And it also records daily and by the second measurement of customer satisfaction with the experience. So based on this, in 2019, there were over 3,000 responses collected. I did not use 2020 data because it was affected by COVID, and there was far less since there was not as much foot traffic. So looking at this data, you can see that generally people are happy. But then when we start looking at it by day of week, when you would expect that perhaps the visitation is different based on days of week, you can see that generally the level of satisfaction is higher on weekdays as opposed to weekends. And this is again the mean satisfaction by hour of day. And that shows a slightly different pattern. And you can see that the level of satisfaction dips during the middle of the day as opposed to the morning and afternoon hours. So what is leading to this kind of differences in level of satisfaction is something that we'll learn after some interviews with the management at Arkia. So here, this is again the total visits by day of week, and you can see there are a lot more visits on Saturdays and Sundays, weekends as opposed to weekdays overall. And customer satisfaction on weekdays is a lot higher as opposed to on weekends, where you can see that the pattern is slightly different, with more people saying that they're not satisfied on weekends. So this again shows the customer satisfaction comparison of weekend to weekdays. And this is the cumulative number of visits by time and day. And you can see that as we, the x-axis is local time in seconds. And generally the level of traffic is a lot higher on, and this is just for by weekday. And you can see generally the traffic level starts increasing towards the middle of the day and then kind of falls off. So what I did was to build a model on customer satisfaction, with customer satisfaction as the dependent variable, and looking at the hour of the day as the independent variable factor, as well as whether it's a weekday or a weekend. So the first model is the adjusted R-square is 0.27, and it's about 2.64 on average, the customer level satisfaction. And the model comparison is with 10 a.m. and Sunday as base. And you can see that in general, the level of satisfaction is about 1 plus point higher on weekdays versus weekends. There's no significant difference between Saturday and Sunday. And if we look at the hour, typically it falls a little as the day goes up, but you can see there the dip is a little bit less around 3 o'clock, and it just it's a little bit less towards the later part of the afternoon. In Model 2, we see similar patterns. Model 2 is slightly different because I also incorporated visits by looking at the number of visitors, and that is slightly better in terms of R-square. And then Model 3, the difference here is I decided to combine weekday versus weekend, since the weekdays were not any different than, that is Monday versus Tuesday was not any different. So decided to combine that and looked at it by weekday as a binary, weekend versus weekday. So this model is with weekday as base and with 10 a.m. In terms of time as the base. And you can see that in general, weekends, the customer satisfaction it's dipping by about a point less. And Model 4 has the highest R-square. And here I also considered interaction effects between number of visits and whether by the hour as well as weekday. And although you can see here that the interaction effects are significant when it's late in the afternoon or early in the morning, between number of visits and the hour. And again, the weekday compared to, weekend compared to weekday, it's a lot less. It dips by about a point. So comparing the models based on AICC scores, you can see that the binary with interactions, visit interactions, has a much lower AICC score, so providing a better fit in terms of the model. So after taking a look at the model and with discussions with management, the operations today, the cleaning is going on only on weekdays. And typically the cleaning is between 8 and 10 a.m. And then there's an inspection on supplies, which happens around 12 p.m., but the management was not sure because they don't keep track of the exact time when these services are provided. So, however, the reality is that the number of visits on weekends is way more and contributes to -1 point difference in customer satisfaction. It holds even when outliers are taken out. And customer satisfaction drops by -0.10 every hour, with it being leased at 3 p.m. So that potentially has to do with the inspection on supplies and replacement of supplies, such as the soap, toilet paper, etc. So day of week has greater impact than time on satisfaction levels. Obviously, the crowd factor is a lot more, the difference being a lot more in terms of visits during weekend versus weekdays. So you can see how real-time customer satisfaction measurement can give input into action that may be taken. And this is based on volume of data. So it's possible to respond to this based on how there are changes in terms of the maintenance of cleanliness in the restroom. So there are some limitations of research. The installation is limited. The number of visits were based on responses as a surrogate. So obviously there's underweighting in terms of looking at number of visits. There are more people possibly visiting who are not actually responding. But given that the response rate on such devices is fairly high, this may not be as much of an issue, but it is definitely underweighting the number of visits. The response to emoticons is based on inference. There's not much research that has been done to compare customer satisfaction measurement using emoticons versus a scale that's a numerical-based scale. So again, this is based on inference. So just an example of how marketing analytics with real-time customer-based measurement can be used, and the kind of data that is provided can be used in making decisions that can improve customer satisfaction.